Good afternoon all and welcome back to our maths class. Yesterday we have discussed about prime numbers and composite numbers. Today we are going to discuss about rules of divisibility. So what is meant by divisible? What is meant by divisible? We will check. When dividing by a certain number and it gives a remainder 0. For example, 10 by 2. The answer is 0. So when dividing by a certain number, if we get the remainder 0, here the remainder is 0, then we call it as 10 is divisible by 2. 10 is divisible by 2. And for example 15 by 3, and here also the remainder becomes 0. If the remainder is 0, we can say that the number is divisible. In this case 15 is divisible by 3. We can divide 15 by 3 with the remainder 0. So for in the case of larger number, suppose 1000 or 2000, so it is very difficult to divide. So there are some rules or there are some techniques for checking the divisibility, whether they are divisible or not. So today we are going to study that. And here 9 is not divisible by 2 because we get the answer the remainder of 1 which is not equal to 0. Therefore we can say that 9 is not divisible by 2. So now I will show one video.
Today, let us study the rules of divisibility. These rules will help us determine whether a number is divisible by another number without actually carrying out the division process. Let us have a look at different divisibility tests. Divisibility by 2. If the number is even, that is, it ends in 2, 4, 6, 8 or 0, we say that the given number is divisible by 2. For example, 26 ends in 6. Thus, it is divisible by 2. Divisibility by 3. If the sum of the digits of the number is divisible by 3, we say that the given number is divisible by 3. For example, look at the number 384. When we add up all the digits, that is 3 plus 8 plus 4, we get the sum as 15. We know that 15 is divisible by 3. Thus, we conclude that 384 is divisible by 3. Divisibility by 4. If the number formed by the last two digits of the given number is divisible by 4, we say that the given number is divisible by 4. For example, look at the number 164. Its last two digits form the number 64, which is divisible by 4. Thus, the whole number 164 is divisible by 4. Divisibility by 5. If the number ends in 5 or 0, we say that the given number is divisible by 5. For example, 525 ends in 5. Thus, it is divisible by 5. Look at this another example. 330 ends in 0. Hence, it is also divisible by 5. Divisibility by 6. If the number is divisible by both 2 and 3, we say that the given number is divisible by 6. For example, look at the number 408. Is it divisible by 2? The number ends in 8. Thus, it is divisible by 2. Is it divisible by 3? 4 plus 0 plus 8 is equal to 12, which is divisible by 3, which makes the number 408 divisible by 3 as well. Hence, 408 is divisible by 6. Divisibility by 8. If the number formed by the last 3 digits of the given number is divisible by 8, we say that the given number is divisible by 8. For example, look at the number 53,888. Its last 3 digits form the number 888, which is divisible by 8. Thus, 53,888 is divisible by 8. Divisibility by 9. If the sum of the digits of the number is divisible by 9, we say that the given number is divisible by 9. For example, look at the number 7,29,639. Here, on adding the digits 7, 2, 9, 6, 3 and 9, we get the sum as 36, which is divisible by 9. Thus, 7,29,639 is also divisible by 9. Finally, let us look at divisibility by 10. If the number ends in a 0, we say that the given number is divisible by 10. For example, 8,620 ends in 0. Thus, it is divisible by 10.
First of all, divisible by 2. Divisible by 2. For example, look at the table 1 into 2, 2 into 2, 3 into 2, 4 into 2. All are even numbers, right? The answer, all are even numbers. So all even numbers are divisible by 2, right? All even numbers are divisible by 2. Or if the number is even, means a number even means it ends with 2, 4, 6, 8 or 0. Then we can say that the number is divisible by 2. For example, 26. 26. The number ends with 6. So it is an even number. Therefore, we can say that it is divisible by 2. But in the case of 13, it is an odd number. A odd number is not divisible by 2. So this is the rule for checking divisibility for 2. And now for checking divisibility by 3. For example, 12 by 3, which is equal to 4. So this is already I know. This is a very simple calculation. But for higher calculation, for example, 996. Suppose we have to check whether this is divisible by 3 or not. So when we divide 996 with 3, we have to check whether the remainder is 0 or not. So for that, simply the rule is sum of digit is divisible by 3. If the sum of digit, so here we have 3 digits and take the sum 9 plus 9 plus 6. So 9 plus 9 plus 6 is equal to 24. If the sum of the digit is divisible by 3, if the sum is divisible by 3, so here the sum 24 is divisible by 3, so that number is also, so this number is also divisible by 3, which means if the sum is divisible by 3, the number is also divisible by 3. And here the case of 384, 384. We have to check whether this is divisible or not. For that, no need of dividing. Simply take 384, add the digits 384, and the answer will be 15. And check whether 15 is divisible or not. 15 by 3 we know it is divisible. Since 15 is in the multiple of 3 or in the table of 3, this 384 is also divisible by 3. And coming into divisibility by 4. So if the number is formed by the last two digits is divisible by 4, we can say that the given number is divisible by 4. So for example, 8, 4, 2, 3, 6, 1, 2, 4. We have to check whether this number is divisible by 4 or not. For that, only check last two digits. Take last two digits. If this 24 is divisible by 4, then the whole number is divisible by 4. For example, if 164, we have to check 164. So it is very difficult to check 164. Then take only this last two digits. If the last two digit is divisible by 4, we can say that the whole number, means the full number 164 is divisible by 4. And divisibility by 5, it is very easy. Check whether the unit place or the number ends the first digit from the right side. If it ends with 5 or 0, then we can say that the given number is divisible by 5. For example, 85, the number ends with 5, so it is divisible by 5. For example, 10, the number ends with 0, so it is divisible by 5. And 12, the end with 2, so which is not possible. For divisibility by 5, only 5 and zeros are allowed in the unit place. And for the case of 525, it ends with 5, so it is divisible by 5. For the case of 330, 0 end with 0, so divisible by 5. So if a number ends with 5 or 0, then it is divisible by 5. Divisible by 6. So if a number is divisible by both 2 and 3, suppose if a number is divisible by both 2 and 3, we can say that the given number is divisible by 6. For example, check 12. 12 is divisible by 2 because it is an even number, and also 12 is divisible by 3 because 3 into 4 is equal to 12, or simply add the digits 1 plus 2 which is equal to 3. 3 is divisible by 3 itself, so we can say that 12 is divisible by both 2 and 3, because if you divide 12 with both 2 and both 3, the remainder will be 0. So 12 is divisible with both 2 and 3. If a number is divisible with both 2 and 3, then it is divisible by 6. For example, 408. Clearly it is an even number, so it is divisible by 2. So the first condition is okay. And we have to check whether it is divisible by 3. For checking divisibility by 3, we have already studied. Take the sum of digits. Here the sum of digits is 4 plus 0 plus 8. Taking the sum of digits, the digit sum is 12, and 12 is divisible by 3. Therefore, 408 is also divisible by 3. So it is divisible by both 2 and 3. So it is divisible by 6. So the condition is that if a number is divisible by 6, means there are two conditions. It must be divisible by 2 and it must be divisible by 3. If the both conditions are true, then it is divisible by 6. And divisibility by 8. If the number formed by last three digits is divisible by 8, then we can say that the number is divisible by, the given number is divisible by 8. For example, 53,888. So no need to check the whole number, only select the last three digits, 888, and clearly 888 is divisible by 8. So we can say that 53,888 is divisible by 8. Divisibility by 9. So if the sum of the digit is divisible by 9, then it is divisible by, the given number is divisible by 9. For example, what is the case of divisibility by 3? Divisibility by 3 means sum of digits. The sum of digit is divisible by 3. Then we can say that the number is divisible by 9. Sorry, 3. But if the sum of digit is 9, then the given number will be divisible by 9. And I will show one example. For example, 18. The sum is 1 plus 8 is equal to 9. 9 is divisible by 9. So therefore 18 is also divisible by 9. For the example of 27, the sum is 9. Therefore, it is divisible by 27 is divisible by 9. So like that. Here also one example is given. 7,29,639. Taking the sum, we will get 36, and we know that 36 is divisible by 9 because the remainder is 0. So it is the whole number. This number is also divisible by 9. And now I am going to check the divisibility by 10, and simply if a number ends in 0, we can say that it is divisible by 10. For example, 280, the number ends in 0, or 180, the number ends with 0, 200, the number ends with 0. So if a number ends with 0, we can say that the number is divisible by 10. 8,620 is divisible by 10 because the last digit is 0. It ends with 0. And one more, divisibility by 11. So last number. So don't be confused with these rules.
Hi, so now we are going to learn the divisibility rule of 11. And this is also one of the very simple rules of divisibility. And here the rule is the difference between the sum of the digits at even places and the sum of the digits at odd places is either 0 or divisible by 11, right? So suppose if we have a number like 50,248. It is a big number, so we have to check its divisibility, right? So what is the first step? First step is we have to identify the digits at even places and odd places, right? So if I start counting from the rightmost side, this 8 will be at odd places. It is the first place. Then this is the third number, and this is the fifth number, right? So what they are saying, the sum of all these digits and the sum of all the digits at even places, if we find the sum of these digits and then find the difference should either be 0 or it should be divisible by 11, right? So the sum of the digits at odd places is 5 plus 2, 7, and 7 plus 8, 15, right? Similarly, the sum of the digits at even places is 4 plus 0, 4, right? And what we have to do now? Yes, we have to find the difference. So to find the difference, what we do? We subtract the smaller number, which is 4 over here, from the bigger number, which is 15, right? We have to do 15 minus 4, and this gives us 11, right? And this 11 is the multiple of 11. 11 ones are 11, right? So this will be divisible by 11. Any number is always divisible by the number itself. 11 ones are 11, gives us remainder as 0, right? So this says, or this suggests that this number 50,248 will also be divisible by 11, right? So let's check the validity of the rule. So for that, we will divide this whole number 50,248 by 11 and see whether we get the remainder as 0 or not. So let me remove all this extra calculation, right? So what we have to check? We have to divide this number by 11, right? 11 fours are 44. 10 minus 4 gives us 6. 4 minus 4 will be 0. If I note down this 2 over here, it becomes 62. 11 fives are 55. right? 12 minus 5 gives us 7, right? And now this is the turn of this 4. 11 6 are 66, minus 14 minus 6 gives us 8 is 0. And now if I note this 8 down, it becomes 88. And yes, 11 8s are 88. 0. So we got our remainder as 0. That means 50,248 is completely divisible by 11. Right? So this was one example. And now I'm going to take one more example in which I would try to get the difference as 0. So this time the number I'm going to take is 1331, right? And again, let's mark the numbers at odd places. These are the number at odd places, right? And these are the numbers at even places, right? And what we have to do? Yes, we have to find the sum of the digits at even places and the sum of the digits at odd places. So in this case, if we find the sum of the digits at even places, 1 plus 3 gives us 4, right? And same is the sum of the digits at odd places. They are also 3 and 1. 3 plus 1 again 4, right? And now if I find the difference, it will be 4 minus 4. This gives us 0, right? So this number 1331 should also be divisible by 11. So let's check it by dividing it by 11. So the number we have to divide is 1331, right? And this we have to divide by 11. 11 ones are 11. If we subtract, 3 minus 1 gives us 2. 1 minus 1 is 0. Let's note this 3 down. 11 twos are 22. And if we subtract, 3 minus 2 gives us 1. And this is the turn of noting down this 1 over here. And again 11 ones are 11. And 11 minus 11 is 0. So we have got our remainder as 0. That means 1331 is divisible by 11, right? So this is the proof of the concept or the rule that if the difference of the sum of the digits at even places and the sum of the digits at odd places is either 0 or a multiple of 11, the whole number or the number itself will be divisible by 11.
So we have to check divisible by 2, 3, 4, 5, 6, 8, 9, 10, 11, etc. Unfortunately, 7, divisibility by 7 have no technique, not yet find, so we no need to study. So take number 990. Divisibility by 2 means it is an even number. So it is an even number, so yes. It is an odd number, so it is not divisible by 2. In the case of 3, we have to take the sum of digits. It is 9 plus 9, 18. 18 plus 0 is equal to 18. So 9 plus 9, 18. 18 is divisible by 3. So also divisible by this 990 is also divisible by 3. And in the case of 4, take last two digit. Last two digit 90. Check whether 90 is divisible by 4 or not. So 90 is not divisible by 4. Therefore 990 is also not divisible by 4. Check whether divisible by 5 or not. If it is divisible by 5, the last digit will be 0 or 5. Here it is 0. So yes. So you have to fill like this. Divisibility by 6. Check whether it is divisible by 6 or not. For 6, if it is divisible by 2 and 3, then it is divisible by 6. So here also 2 and 3, it is divisible. Therefore for 6 also it is divisible. And in the case of 8, take last 3 digits. You have to take last 3 digits. So so the remainder is not 0, therefore it is not divisible by 8. In the case of 9, if the sum of digit is divisible by 9, here 18 is divisible by 9, 18 is divisible by 9, therefore 990 is also divisible by 9. For the case of 10, look at the last digit is 0, so it is divisible by 10. And for checking divisibility by 11, take divisible for case of 990, check sum of digits at odd places, so 9 and 9, then sum of digits at even places, this is an even place, so the sum is also 9, so the difference between this is 0, 0 is divisible by 11, so 990 is also divisible by 11. So if you have any doubts, kindly go through the previous video and don't copy it from your textbook and all, so kindly clarify yourself, and you have to do this much homework, and you have to submit it by Sunday evening. There are a lot of homeworks I know, so before Sunday evening you have to submit. Now the second question is about check divisibility by 4 or by 8. Check this is divisible by 4 or this is divisible by 8, and like that. And the third question, you have to check whether it is divisible by 6, the following numbers. If it is divisible by 2 and 3, then it is divisible by 6. If it is divisible by both 2 and both 3, then the number is divisible by 6. That is the divisibility rule for 6. And this we have to check by 11. The rule we have already studied.